If there is anyone on Zoom, can you see my
Okay.
screen and can
This
you
one
hear
has
me?
linear terms, so why would this?
Yes.
Okay, all right. So,
Are you going?
this first question is a little bit of a trick, except it's not. You can do it the long way, but the answer is actually quite easy because it's asking for the average value of the given voltage waveform.
It's not 0, is it?
It is 0.
Oh my god.
Because
Oh, that
it's not root mean square. It's not root mean square, it's just average value. So you have the same area above and below because it's symmetric. And so if you were to add up all of the area above and all of the area below and divide by the interval, you would get 0. And so the average value is 0. Now, you can also find the average value by taking the integral from 0 to 300
I prefer the
of I'm probably not going to do this by hand, but it's not hard.
Yeah.
So you have to know the equation for this. It is a sine function. It has amplitude 5, so it's 5 sine. You have to know the angular frequency. So the angular frequency is the so frequency is 1 over the period, and angular frequency is 2 pi times the frequency. So the period is 300, so the frequency is 1 over 300, and so the angular frequency is 2 pi over 300, or pi over 150. So that's pi over 150 t. There's no phase shift, so there's no angle there, dt, over the length of the period, which is 300. And if you do that integral, you get 0.
The entire integral is over 300? Or?
The entire integral is over 300, and you would get 0.
Okay.
Usually the average value theorem is given with the coefficient 1 over t.
Yeah, okay.
Yeah. Yeah, I have it in my head as integral over interval, and so I just do it like that. But so 1 over t works the same way.
Okay.
If it had asked for root mean square, you would have had a different answer, but how would we get the root mean square? We need this for a later problem. But
Square the integral.
Yeah, squared.
so that you'd have the square root of the integral from 0 to 300 of 5 sine pi over 150 t squared dt, sorry my handwriting is so bad, over 300. But there's a much easier way because this is a sinusoid. So the root mean square of any sinusoid is the amplitude divided by the square root of 2. So the root mean square, so if we did this integral, we would get VRMS is 5 over the square root of 2 volts.
Would the 300 not be inside the square root? It's 1 over
The
2 pi.
3,
Oh wait, yeah, no.
it is inside the square root.
Why is it that sometimes there's a 1/2 in front of that RMS equation? Like 1/2.
It
The
depends
only
on
time
whether
there's
it's
a 1/2
RMS or
in
not.
front of it
Oh,
is
that's power.
when you're
It's two
doing
1/2.
power, because
There's two 1/2?
here's the
Oh,
1/2 deal. So VRMS equals V max over the square root of 2. Now V max is the same as
Oh, we hate when people do that.
amplitude, it's the phasor value. So if I want to find the complex power, that's VRMS times IRMS. But if I take my peak instead of my RMS, that's V over the square root of 2 times I over the square root of 2. And square root of 2 times the square root of 2 is 2, so that's 1/2 VI. So if you're using peak instead of RMS, then you have to remember either the square root of 2 or the 2. You have to remember that you have to always pay attention to whether you're using peak or RMS.
What is so the VRMS equals what, 5 divided by
Square root of 2.
square root of
Yep. Okay. Determine the real power absorbed by the load if V is the voltage in the waveform. So for this one, we would need to find the equivalent resistance, which would be, so these are all real. So we have 1 and 3 make 4. 4 in parallel with 4 is 2. 2 in series with 1 is 3. So our R equivalent is 3. So in this instance, if we want to find the real power absorbed by the load, I think I'm going to say that if our complex power is complex 1/2 complex voltage times the complex current, and the current is the voltage over the impedance, but our impedance is all real.
Is it current conjugate?
Conjugate. But if our impedance is all real, then can't we just say that it's 1/2 magnitude of V squared over R?
Why is it 1/2? Oh, yeah, because of the
Well, it's, if I use the RMS, I don't use 1/2, but if I don't use the RMS, I do use 1/2. So 1/2 25 over 3. Which is, I believe, about 4.2 watts.
Yes. Yeah. It's 4.16, but
Okay.
yeah.
If the frequency of the source is 10 kilohertz in the circuit below, what value of capacitance would cause the source voltage to be in phase with the current? So we have 10 ohms. Our equivalent impedance is 10 plus J3 ohms minus J over omega C. We want this to be real, a real number. So what that means is J3 minus J omega C has to be 0. I can now get rid of the J, so 3 minus 1 over omega C equals 0. Omega is 2,000 pi, 20,000 pi. Because the frequency is 10 kilohertz.
Times 2 pi.
So angular frequency is 2 pi times the frequency. So it's 20,000. So it's 3 minus 1 over 20,000 pi times C equals 0. Or 3 equals 1 over 20,000 pi C, or 60,000 pi C equals 1, or C equals 1 over 60,000 pi. So can someone tell me what 1 over 60,000 pi is?
5.305 e to the negative micro, yeah.
So 5.3 microfarads. determine the reactive power of the equivalent impedance as seen by the source.
Assume that it's I would immediately redraw by circuit because
Oh, yeah.
Yeah.
This circuit
it's
needs
so
redrawing.
terrible.
Yeah, I don't.
This circuit
like,
needs serious redrawing.
I'll
Okay,
need to
so
make over.
neatly redo that problem as if it had no mistakes with all the right answers, and I'm gonna cut out the bad part before I upload it. Okay, so for this problem, we
Like an
had
ancient historian.
a resistor, and we had a current source going down, and we had
Professional history
a
minor right there.
resistor and a capacitor. And we're supposed to find the reactive power of the equivalent impedance as seen by the source. So the first thing is to redraw it just so it looks a little more normal. And by normal, I just mean the way I like it. And so this would be 10 angle 20. And this is 3. And this is 8 and minus J2. So we found Z equivalent, and Z equivalent is, this is parallel, so it's a product over the sum. Am I reading that wrong? Is that a 5?
It's a 5 and 3.
Yeah, 5, 3, negative J2.
That's supposed to be a 5.
No mistakes.
I know, I already made a mistake, so this is not acceptable. 8 minus J6, so, J2, J2. And then we got, when we do this, we got Z equivalent as a phasor was
1.96, angle negative 7.77.
ohms. Then, once we had that, we found the voltage just using Ohm's law, so V equals IZ. So V equals 10 angle 20 times 1.96 angle negative 7.77, and that gets us 19.6 angle 12.23 is our voltage. And then we get our complex power by taking 1/2 V 19.6 angle 12.23 times I conjugate. And I conjugate is 10 angle negative 20. And then when we get that complex power and we multiply that out, we got a value of, help me out here, otherwise I'll have to scroll up to all the messy work and then they'll know that I'm like pretending like I don't make mistakes.
98 angle negative 7.7.
Angle negative 7.7, which if we write that in rectangular gives us
97.1 plus or minus J 13.2.
And so our reactive power is Q is negative 13.2 VAR, which we know has the right sign because it was capacitive. All right, very good. All right, so stop this one.